This time I'm going to wear my hat as being one of the participants in the Scottish COVID Response Consortium, which we'll be telling you a bit more about. Okay, so I'm going to tell you about what EPIC did and then just kind of run through some of the lessons that we think could reasonably learn from our experiences. So we're very, very pleased that VSAS and Animal Health and Welfare Division were open to the idea of us trying to do some COVID work. With some very reasonable and sensible caveats that we did make great efforts to maintain our core kind of delivery, for animal health and welfare, as mentioned by the ongoing work in avian influenza over the 2 winters. But subject to that, we were able to try and basically deliver some useful work on COVID. But it's fair to say that certainly a lot of us were also keeping one eye on the longer term advantage to animal health and welfare work throughout the whole process. The main mechanism for us doing this was the Scottish COVID Response Consortium, which we'll just call SCRC from this point onwards. So this was basically a group from EPIC, a group of some of my other colleagues from BIOS, and a group of some of our other colleagues from the Boyd Orr Institute at the University of Glasgow. And actually, Richard Reeve from the Boyd Orr was our kind of the lead on the activity. And unfortunately, he can't be here today because of the strike action. So we came together and won support from the Royal Society, which was an initiative that they had put together to provide in-kind support to various kind of research activities. And with all great resources, let's see what we can get out of this. So we were successful in winning this. And we got such great resource. Now, the 3 kind of areas that we got a lot of support from are research software engineers. So in the old days, these people would be called programmers, and there's a kind of an effort to kind of give more emphasis to the actual creative and highly skilled contribution that scientists with these skills can make to our work. And the research software engineers came from all sorts of places, including UK Atomic Energy Authority. We also had some work on expert visualization and uncertainty quantification. But we're not going to talk about those because I don't know as much about them. And although they're interesting and they are kind of progressing, I'm going to focus more on the main pathways out of this SCRC that are feeding into EPIC 4. What was nice was, to be honest, I think it did start off being a bit transactional. We were thinking, great, we could do some work and get some people to do some work for us. But it's been really nice. It has evolved into genuine collaborations. Mark Birchley is now having successfully won further money in a collaborative project from UKRI to progress this stuff onwards. So the first area of work I'm going to talk about is some of our modelling activities. So these were the 5 EPIC scientists who did most in terms of developing modelling capability in COVID. I'm not going to talk about the work that Thibault and Paul did, not because their models weren't good, they were very, very good, but it's because the other 3, again, there's a more clear pathway from what they did into what we're going to be moving forward in. So, looking at what we do in EPIC, if there was an incursion of an exotic notifiable disease, I strongly would argue that what we most need is a particular type of model. Very, very, very much data-driven, not assuming that the last epidemic will be the same as the next one. Now, there's probably nobody in the room that actually understands the significance of the map on the left-hand side there. People who were around in the late 60s would definitely recognise it without blinking. That was the FMD outbreak in the late 60s. Whereas the one on the right we all recognise still as being 2001. There were different epidemics. There was no viral plume, or no major viral plume in 2001 the way there was in the 60s. So it's much better to basically not make strong, wide-ranging assumptions about how things are going to behave. It's better to actually look at the data. How is the epidemic evolving in the system as it is currently in place? But then the model does have to be complex enough to answer the questions that we want. So this is a particular type of model that's worth pursuing. And the work that my colleague Chris Pooley did for COVID was very well directed towards this objective, Poor Chris, he joined BIOS and EPIC 1 week after lockdown started. So he's probably very, very happy to be here today and meeting us all. His focus was on this type of very rapid inference, being able to get data in and turn it into meaningful evidence very, very quickly. So he developed a model for COVID-19, and the maps there on the right show some of his inferred maps of R, which is now, at least I don't need to explain to anybody what that is, at different snapshots just before lockdown. You can see things were spreading rapidly, and then just after lockdown, and then 1 week after lockdown, thus showing the actual efficacy of what was done in terms of government policy. So the key things here is it's data-driven, and so it's applicable to any kind of disease that has got where we can get data and it's got like a spatial temporal structure that we're interested in understanding, which pretty much summarises any exotic disease incursion that's notifiable. So the plan would be to move this work forward into diseases like ASF and FMD. Another major strand of work was done by Sibylla at the University of Glasgow, and Theo has helpfully talked about some of this model structure already this morning. It's the FMD movement and standstill model. Again, its particular attribute, which I think makes it appropriate for that purpose, was that it's focused on the individual, in this case, the individual premises, but also has got the large-scale kind of structure over the whole country, which actually meant that it mapped really quite sensibly across the COVID contact tracing problems. Same issue. You're interested in the individual and their interaction with a much wider collective. So that model gives an appropriate framework for this work. Whether what you're trying to do is establish, what sort of contact protocols should you be tightening up in? How long should people isolate for? How to improve the process? Which parts of the process should you invest money in to speed up? Is it worthwhile trying to basically contact people 24 hours after rather than 48 hours? That's the thing that this model is very, very good at. So Sibylla had developed this model. To be honest, we did not manage to get any traction on it being used for public health purposes. And that kind of plays into one of the kind of key lessons which we knew already, but it just reinforces it. That this thing like this is best done by co-construction in advance, because then the actual assumptions that the policy people want to make are already built in, the trusted relationships are there, and there's a readiness and willingness to understand and engage. The third bit of modelling I'm going to talk about is, again, a different type of model, where we're not going to try to infer from data so much about what is actually going on, but we want to run lots and lots of different simulations to explore what might happen at a very, very fine spatial temporal granulation. So we assume that we know roughly how things are going to spread, perhaps using some of the information that Sam can provide for avian influenza from her phylogenetic generalised model. But we want to run the model very, very quickly. So this is where we get into very unhealthiness. Because Claire Harris, who again had joined BIOS fairly soon before lockdown, in the previous year, had a model that she had been working on in her PhD to model biodiversity at a very, very fine spatial temporal scale. So what she did within the SCRC consortium was to re-engineer it to include spread, because that's what diseases do. And actually a lot of very clever mechanisms to be very flexible in modelling that spread. Now, I'm not going to go into this slide in detail. The key point being is that a lot of the things that we want to get from the type of model that we'd be wanting for avian influenza or any vector-borne disease, for that matter, has now been put in place in this COVID model. Plus, but one of the bits that I think is very important, it can incorporate very highly detailed covariate data. So again, as Sam's presenting, some parts of the country have got lots of wildfire, other parts of the country don't. If we have that data, it can be built into the model which then will run very, very rapidly and let us explore a lot of different scenarios to inform policy. So I've talked about three very different models, and I find it quite useful to at this point to step back and say, well, how does this all hang together? Because it's definitely useful to think about why are we doing any particular piece of modelling work. But the reason why is usually depends on the how and when and who. So the choice of methodology, which will be totally driven by why we're actually doing the work. These are three very different models for very different purposes. But it's also useful to think about who is going to use it and at what point in well, it's not really the policy cycle, the policy response. Because the models that are needed before an outbreak are different to the models that are needed in the immediate and during an incursion, which in turn are different to the ones that we'd need if it turned into a 4-month, 5-month, several years long epidemic. But what I think is a useful point to make is that when we're looking at something like Claire's model, which came from biodiversity, very, very different domain, the linkages between what she was doing in biodiversity and what we can use it for in EPIC aren't direct. They actually map across on the choice of methodology and the when and who is going to use it. So one of the issues that arose during this work was, particularly Chris's work, was access to data. By definition, if you've got a model which requires data, it's not going to be very much use if you don't actually have that data. At best, it's a bottleneck. At worst, forget it. And unfortunately, that's our friend GDPR in the bottom right-hand corner. Things are getting more stringent. Now, as Julie presented earlier, EPIC has done a lot of work in preparing and pre-planning. But is that actually enough? So one of the things that we're thinking about is to actively think about how to make our models more robust against the availability of data, which I've called data de-risking, because it's quite nice to have a fancy buzzword. The idea there would be, if we can get useful results using non-disclosive data, then one, that actually is what we should be doing in light of the GDPR obligations, but also it will be more robust and safer, because that, by definition, should be data that we will have easier access to in the event of an outbreak. So not actually always looking for better data, but perhaps trying to make better use of the data. I would say that, I'm a statistician, but it's a good point. Now, another major area of work in the SCRC was that of data pipelining. Our realisation was that if we were actually genuinely responding and supporting policy colleagues in an outbreak, it would be horrendous. The data that we would be drawing on would be constantly updating. If we realised that the models needed to be changed, the models would be updating. It would all be happening in real time under constant pressure, and there's hopefully a flow of reportage going to the Animal Health and Welfare Division. And guys, it was really, really important to know the provenance of any particular output. Now, those of you who know me will be shocked that I've put a picture of Prime Minister on a slide, but this particular press conference is slightly infamous, because that was the one where they managed to present a slide using modelling results that were about 3.5 weeks out of date. As it happened, it didn't matter. They were actually in line with the kind of uncertainty range that was being produced by the more recent models. But this was picked up by the media, and Professor David Spiegelhalter commented on it, that the problems that this actually flagged. It could have been really bad. If some elements in the media or society were able to present them as being actively trying to mislead and make policy decisions on the basis of faulty evidence, it could have got very, very nasty indeed. So understanding the provenance of outputs is really important. And in the EPIC, what we can anticipate is that, well, yeah, it's not maybe as complicated as some of the situations, but it's fairly complicated. We've got the data team looking after data flowing down, a lot of that being worked on by the modeller, largely managed by the modeler to some extent, producing either visualizations or reports which then go through the policy broker and thus to government. You know, there's a lot of steps along there, a lot of scope for things to go wrong, and a lot of flux in actually what's going on. So it's really important to manage some of the information well. And that's what the fair data pipeline that we've created in SCRC is setting out to do. Don't worry about the pretty picture, though it is actually a technical specification. Thanks, Aaron. So basically, Aaron designed a data registry to store this metadata. And the work has gone into actually building pipeline APIs around this so that the information the metadata is automatically managed. So that if a modeler runs a model based on a particular block of data, the metadata is automatically collated that it was run using model version 4.3 on such and such a date, using data set 1, data set 2, data set 3, and all the provenance being recorded automatically. I'll just give you the practical impact. If at some point we decided that a data set was wrong, was invalidated, you can flag it into the system as being invalid, and that status can propagate through to then say, so these reports need to be withdrawn because they are no longer valid, which we felt was, for example, a very useful facility to have. So, the last point, the lessons learned in EPIC. So, the pressured events definitely incentivised a lot of really, really nice work, as I've just been presenting it. But in balance, it's really not the best way to work. It's better not to rely on this. The whole co-construction model in advance is better. RSEs are important and really, really valuable. And we've got more links now with the Society of Research Software Engineering, who are trying to promote this very, very useful role. And very nicely, of course, we've realised that we can indeed successfully leverage extra resources into EPIC. It's something we talked about a lot in the past, but had never really gone for. But I think we actually can see the value in this as something to do. It's very clear, it is really, really useful to think about trying to be very clear in our minds about why we are doing any particular bit of modelling work. That why is this model useful? What is the policy question that it is seeking to answer? And how is it actually going to help answer it? And by building that into all of our processes, I think we're going to produce, we will aim to produce much more effective outputs. What I was saying earlier about de-risking modelling work relative to data, I think is going to be very important. And the whole thing about pipelining to improve provenance is both useful and also very, very much in line with the RESAS's strategy, which they've been putting out for open science. So again, it's both useful and well aligned with our funders' priorities, which is a very nice situation to be in. So I'd like to acknowledge a lot of people, basically all the rest of the SCRC, but in particular these people, because Chris, Sibylla and Claire have kindly given me slides and let me talk about their work. My colleague Glenn, who was very much in the lead focus on developing the mathematical modelling side of things. Richard for leading us all, and very much leading the development of the data pipeline. My colleague Ruth Dundas, who basically, along with myself, has led on the data aspect of things in SCRC, and Aaron for basically being there and basically providing the initial specification for the data registry. And that's me. Thank you very much. Ooh. Questions? If Ali's still online, this is probably a good time to ask your pipeline question again. And Nick.
So, thank you, Ian. Can you please give us just any details, or maybe share this time I wrote it down, your view on how these models were adapted to the COVID scenario conjuncture? The preoccupation being that we may be running the risk of reducing sociality to like this kind of environmentally conditioned behavior, say to what we have in common with, I don't know, poultry.
I'm sorry, the sound is actually genuinely really hard. Could you give me the key point again?
I'll read it
please?
again, maybe. Just wondering if maybe you could please give us some details or your view on how these models were adapted to the COVID scenario. And my preoccupation behind it is that we may be reducing sociality to this environmentally conditioned behavior, to what we have in common with, say, poultry. And of course, that also leads to the question of provenance, which is, I think, rather directed to the questioning of the models themselves and the kind of, social pariahs that they're, in a way, dissimulating.
Yeah, that's actually a harder question to answer than you might have realised, because of the three that I presented there, the only one that actually had the direction of flow being EPIC work being converted into COVID work was Sibylla's model at Glasgow, which ironically, I have to admit, is the one that I know least about. Whereas Chris's model was basically set up from the word go to be COVID oriented, although he had previous work in Roslin on other application areas. And similarly, Claire's model was taking it from biodiversity into COVID. And now the longer term plan is to move them from the COVID into animal health applications. So I think a lot of what we did doesn't actually map to your kind of model of the change. And I think some of the underlying question isn't really there to the same extent. Sorry.
Thanks, Ian, and thanks for that lovely reminder of how I spent the hottest summer in memory in a very hot shed at the end of the garden, so thank you for that. First of all, just to really emphasise the point you made about getting us epidemiologists to work with the research software engineers, for me and I think for everybody else who's basically hacked together code, to be working with people that do this properly really taught us some really good practice. I just want to ask you a sort of more broad question about how, going forward with these models, we can sort of make them more nimble. We sort of started, as you said, basically saying who's got some modelling framework we can adapt. And whilst it would be lovely to be prepared and have a model on the shelf for every disease eventuality, we're probably going to be presented with a disease situation we hadn't thought about. So do we need to go through an exercise, or do EPIC need to go through an exercise of sort of how to be nimble with models and how we can minimise that sort of overhead burden for adapting a model to a new situation, or sort of how we go about, how we do that in best practice? I'm sure the pipeline's involved in that, but thanks.
No, I think you've put your finger on one of the most difficult, the problems being, if we could predict the future, it would be really easy, but we can't, even though, because we can't really model that aspect. Various pronged strategies, I think, is probably the best way forward. One thing which we are planning to do in EPIC 4 is actually the opposite of what you've suggested as part of the portfolio, which is to engage with the work that T1 has been doing already, talking to policy colleagues and continuing to engage with policy colleagues, obviously, to identify priority questions that we can anticipate being asked in the event of particular incursions. And then actively seeking to kind of create a qualitative meta model, is that the right term? To actually, what will that situation be? What will it be like? What data will we have access to? What modelers will we have access to? And basically, if necessary, then fine-tuning our response. So basically, we're concerned we will have an algorithm that we want to use. If we don't, we'll have to write it, to answer that particular policy question. But in that wider context of also, okay, there's no point having an algorithm that answers the question where it's assuming that we will have access to a full data set, when actually the policy requirement is for us to be providing evidence a day before the main data flow comes on tap, and we'll be making do with patchy data, so that trying to actively understand the context that the question is going to be asked, modelling it, and actually trying to fine-tune our response in advance. Obviously, kind of deals with the known unknowns. The unknown unknowns are more difficult, which is what your question was kind of tapping into. And one of the ways that we're going to try and do that is to try and do some more work in what's going to be Challenge 6, to bring all the quantitative people and actually some of the other EPIC researchers together on an annual basis to kind of focus on particular issues. So it's like, what are we going to do about avian influenza? What are we going to do about such and such? Again, just to openly try to brainstorm what kind of solutions we might have as a collective, and then who within the collective is best placed to move them on, and if they're worth moving on with. And then, because if they are worth moving on with, we'd then seek to embed them as deliverables in some of the other challenges in later subsequent years. So between those two kind of range bits of the spectrum, hopefully we'll cover an awful lot of the eventualities.